Hello everyone, welcome to the another lecture of alcohol, phenols and ether. Okay, so in the last class, as you can see, we have done the introduction, nature of alcohol, reactivity and basicity, react as acidic nature. Okay, relative acidity, relative basicity, we have seen. We have also seen the classification, right? And after that we have seen the classification. Okay, and after that we have seen the nomenclature. Okay, as you can see here, we have seen the nomenclature. Okay, and now we will see isomers in alcohol. So when you talk about the isomers in alcohol, they are of four types. One is chain isomer, another one is position isomer, and the third one is functional isomer, and the fourth one is optical isomer. Okay, so you can see here some of the example I have given you. I hope all of you know what is isomer, right? So this is an example of, as you can see, these are some of the example of chain isomer, and here you can see the example of positional isomer. Okay, and here you can see the functional isomer. When you talk about the functional isomer, the main formula is this. Okay, CnH2n plus 2O, and from here we can make either alcohol or ether. As you can see, this is example of alcohol and this is example of ether. In ether, you see both sides this CH3 should be there, right? CH3O, CH3 should be there. If only one side is there, then it will not be in ether, right? So as you can see, from this functional group, we are making here either alcohol or ethers. Okay, now next is optical isomers. As you can see, this carbon, when we talk about this carbon, you see here four different groups are attached here, 1 2 3 and 4, right? So these four different groups are there. So since this carbon is what, this carbon is chiral, right? Here also, as you can see, this is what, they both are optical isomers of each other. As you can see, this carbon is also, this carbon is also a chiral. As you can see, this star mark is here, here different group, here different group, here in the back side there is hydrogen, and here it is OH, right? So these are all the example of optical isomers. Now we will see preparation of alcohol from alkene. Okay, so it is a very important topic. So since when we talk about the preparation of alcohol from alkenes, this is carried out by three methods. First method is Marconi-off rule with rearrangement. Okay, another one is, first of all, what we are doing here, we are taking here a alkene. Okay, and in that alkene, through this double bond, what we are supplying, what we are adding H2O here, right? And what we are getting an alcohol. So this process, addition of alcohol and addition of water, is called, this process is called hydration. So this hydration of alkene, or we can say the hydration of alkene to convert into an alcohol, it can be carried out by three processes. Okay, one by one we will see. The first process is Marconif off rule with rearrangement. Okay, and as we know that when there will be a rearrangement, there will be a formation of carbocation, right? So for the rearrangement to happen, they should form carbocation, right? If carbocation will form, then definitely there will be a rearrangement, right? So in this case, Markov of rule here, what is happening here, rearrangement is taking place. Okay, now next is Marconi off rule, no rearrangement. Okay, and this is also called OMDM. OMDM methods means what? Oxymercuration demercuration reaction. Okay, OMDM reactions. Okay, now next is, third one is anti Marconeff rule. Okay, and this is also called hydroboration oxidation. This is also called hydroboration oxidation. Okay, now next, as you can see, when we are taking Marconic off rule, at that time when the rearrangement is taking place, at that time what we are using here H2O or H plus, right? And when there is Marconic off rule, when no rearrangement is taking place, at that time we are using OMDM. This called OMDM is what? OMDM is oxomercuration and demercuration reaction. Okay, and at that time what we are using, as you can see, HgOAc 2 times, or NaBH4, right? Now next is anti Marconi off rule, or here what we are using, here we are using HBO, which is hydroboration or oxidation. Okay, and for this what we are using B2H6, H2O, H2O2, or OH, right? So one by one we will see this. So first one is by acid catalyzed hydration of alkene. Okay, so when we talk about the acid alkaline, by acid catalyzed hydration of alkane, so this is also called what, Mm, indirect methods. So in this method what is happening, alkenes are passed through here what you can see, alkene is passed through a concentrated H2SO4, okay, to form alkyl hydrogen sulfide, which upon hydrolysis with boiling water gives alcohol. Okay, or you can see here what is happening here. Here this alkene, here this alkene, by taking with the help of this H2O, okay, it is converting into alcohol. As you can see here, the compound is what, Marconi of orientation is taking place here. Okay, and as you can see this reaction, here CH3 is there and here H is there. So always remember that the hydrogen will go to that place where hydrogen is maximum. Okay, hydrogen will go to that place. The addition of means what, hydrogen goes to that carbon atom whose contains large number of hydrogen atom. Okay, so here you can see in this place hydrogen atom is more, so the hydrogen atom which will generate from here, it will go here. Okay, and OH will always go to that place where that carbon where hydrogen is less. Okay, so it will form here like this. Okay, compound. And one more example is here. As you can see in this example, again the same thing, hydrogen will go to the place where in which carbon contains large number of hydrogen, and OH will go to that carbon who contains less number of hydrogen. Okay, so you will understand very carefully when you will see the mechanism. Okay, so what is happening here, first of all, in first case what is happening here, you see in the first case H2O, okay, H2O is taking what, H plus ions, and it is converting into what, hydronium ion, right? So in the first case it is like this. First case we can also tell like this, the alkene get protonated. Okay, from alkene get protonated and to form a carbocation by electrophilic attack of H3 hydronium ion. Okay, so in the first case, as you can see, this H2O is taking this H positive and it is converting into hydronium ion, right? So now what will happen, this hydronium ion, as you can see this is an hydronium ion here, so alkene will attack to this hydronium ion. Okay, not hydronium ion will not attack to alkene, alkene will attack to this hydronium ion. Okay, so when this alkene will attack to this hydronium ion, at that time it will form a carbocation here. As you can see, it will form a carbocation here, carbocation is forming here, right? As you can see, carbocation is forming here. So when this carbocation will form here, and this will come out from the reaction, as you can see. Now in the second case, the nucleophile, in the second step, as you can see, the carbocation which has formed here, it will undergo rearrangement, right? Because I have already told you when we were discussing about haloalkanes and haloarine, at that time I have told you, right, that if there is a formation of carbocation, then there must be a rearrangement. Okay, so there will be a rearrangement. Okay, and after the rearrangement, this H2O which is generated here, so this H2O here, in this case, in the second step, the nucleophile, the H2O will behave as a nucleophile, and it will attack to that carbocation to form protonated alcohol. Okay, in the second case what is happening, this H2O is behaving as a nucleophile, as I have written here. This H2O will behave as a nucleophile, and it will attack to that carbocation, and it will form protonated alcohol. As you can see, it is forming a protonated alcohol, right? So now next, after the formation of protonated alcohol, what will happen in the third step, loss of hydrogen from oxygen and loss of H positive ions from oxygen, or we can say deprotonation, will take place to form alcohol. As you can see in the next case, since this oxygen is carrying a positive charge here, then there must be it will, what it will do, it will lose its hydrogen, right? So what is happening here now in this case, in the third case, as you can see, this base, this hydro H2O is behaving as a base, and it will attack to this hydrogen. We know, right, that base always attack to hydrogen, right, and nucleophile always attack to carbon, right? because in this case you see, when it was behaving as a nucleophile it was attacking to this carbon, right? But in this case when it is behaving as a base, it at that time it is attacking to hydrogen, as you can see. Now when it will attack to hydrogen, it will take the hydrogen from here and it will convert into hydronium ion, right? As you can see here, it will convert into hydronium ion here, right? And this alcohol will form here. So I hope you have understood the first method, which is by the catalytic by acid catalyzed hydration of alkene, right? So as you can see some of the example, if you talk about the example, as you can see, suppose we have this example, we have this compound like this here, suppose double bond, and if you are applying here H2O or H plus, so what will be the product will be here, hydrogen will form here, as you can see, OH will come here and it will be like this, right? Now second example, as you can see in the second example also we can see like this. Here in this case what will happen, here the hydrogen will come here, as you can see, OH will come here, right? Now in the third case also you can see there will be a ring expansion, right? Since double bond is here, right? So what will happen, the carbocation will form here and this ring will first go an expansion, and when this ring will expand after the expansion, what will happen, this ring also will expand, and will expand after the expansion, both will form like this alcohol, right? So I hope you have understood this. Now next method is by oxo mercuration and deoxomercuration process, OMDM process, okay? So when we talk about the OMDM process, generally I will first of all I will give you a general idea about this, what is happening here. In this process alkene react with mercuric acetate, okay, CH3COO 2 times Hg, or HgOAc 2 times, okay, in presence of water to form oxomercuration, okay. And after that, after the formation of exomercutions, after that what will happen, adducts which upon reduction with NaBH4 in alkaline medium gives alcohol, okay. Now first of all what is happening, alkene react with mercuric acetate, okay, in the mixture of THF and water to give what, hydroxyl alkyl, okay, and mercury compound, hydroxyl alkyl and mercury compound will form, okay. And after that what will happen, involving addition of OH or HgOAc to the double bond. This process is called what, oxomercuration process, okay. And in the second step what will happen, the sodium borohydride will reduce this HgOAc and replace it with the hydrogen. This is called what, demercuration, okay. So we will see one by one. In the first case, as you can see what is happening here, in the first case, this in the first case as you can see this alkene, and here it is reacting with this H2O, and here what we have used, HgOAc 2 times here, okay, in presence of THS, okay. So here first of all what will happen here, oxomercuration will take place, okay. So as you can see what is happening here, the it is forming like this, okay. As you can see OH will come here and HgOAc will come here, and again after the in the presence of NaBH4 it will form alcohol, right? We will see what is happening here. So first of all, in first case, as you can see in the first case what is happening, this compound, okay, there is an heterolytic bond, the fusion will take place, and this bond will break, okay. This bond will break here, as you can see this bond will break here, and it will convert into two parts, one is this and another one is this, as you can see, one is this part, one is this part, and another one is this part, okay. So after the formation of this compound, what will happen, this alkene, listen carefully, what will happen, electrophile attack, form a mercurinium ion, okay. So as you can see in the first case mercurinium ion is forming. So how it is happening, as you can see here, in the first case this alkene is attacking to this Hg and OAc, right? and in the same time the vacant d orbital of this Hg is there is having a 2 electrons, right? So it is giving its electron to this carbon. Okay, so at that time it is forming like this compound, as you can see here. Let me draw here, right? Let me draw here. It is forming like this compound. It is forming like this carbon, here carbon, okay, and here Hg like this, and here OAC, okay, like this here positive. So this compound is forming here, as you can see here, and in this case no carbocation is forming, right? As you can see, carbocation is not taking place because this process is second process. What was this process? Oxomercuration or demercuration reaction, right? So in this process no carbocation is formed, as you can see. I have also written here. So this is the first process where we have got this. What this is mercurinium ion, right? Now after the formation of mercurinium ions, what will happen in the next case? Water upon the rings to give the organomercurial alcohol, as you can see here, this one. What will happen? This H2O will attack to this carbon. Okay, so when it will attack to this carbon, after that what will happen? When it will attack to this carbon, it will form like this, as you can see here. Okay, and always remember that when you talk about stereochemistry, at that time one will be below the plane and another one will be above the plane. Okay, as you can see here, right? So this will form what? Organomercurial alcohol. Okay, and hydronium ion will come out from the reaction. As you can see, this one is below the plane and this one is above the plane, right? Now next place, this was about the this one, whatever we have learned up to this step. This is what? Oxomercuration. Okay, now we will see demercurations. So when we talk about a demercuration, in demercuration, what is happening? The NaBH4 what we are using, it will just what it will do, demercuration replaces, what is happening here, replaces the mercury fermented fragments with the hydrogen to give alcohol. Okay, as you can see, NaBH4, what it is doing, it is just, as you can see the product, it is just taking this HgOAC from the reaction. Now always remember that the pH of this reaction will be greater than 12. Okay, after if it is less than 12, then no reaction will take place. Okay, so as you can see, this NaBH4 is taking this HgOAC and it is forming like this, okay, alcohol, and after that NaBOH4 will come out from the reaction, Hg will come out from the reaction 4. And this reaction, always remember that this reaction is a very dangerous reaction. Why? Because there is a release of mercury here, right? And the mercury vapor will come out from here, and mercury vapor, we all know that it is very hazardous to our health, right? Now, so I hope you have understood this method, oxomercuric and demercuric process, okay, OMDM process. Now next is, as you can see some of the example, if we are using here hydronium ion, what will be the product here? This one, right? And again the place, again if we are using OMDM, then at that time, since rearrangement is not taking, carbocation is not happening, not forming, so at that time the product will be this. Okay, and for this also the product will be this. Let me draw here clearly. Suppose we are taking this example, same example what we have taken for that acid catalyzed hydration. So at that time, or we can say at that time, Marconif rule for rearrangement, at that time product was this, right? At that time when we are using H3O positive, at that time what was the product? This was the product, right? OH was here and this was like this, right? But in the place of this, if we are using here OMDM, okay, OMDM, at that time the product will be different. As you can see, product will be this, because since the rearrangement is not taking place, right? Now again for this, if we are using this type of reaction, if we are taking this, since rearrangement is not taking place, and if we are using here OMDM, so at that time what will happen? The product will be like this. So I hope you are understanding this. So now next is third process, by hydroboration oxidation process, which is HBO process. Okay, so this process is also a very simple process. Here what is happening, let me explain you. Here alkene react with diboron, okay, H2 B2H6. Here what is happening, here alkene is reacting with diboron, which is B2H6. okay, and to form what? Trialkali boranes, okay, trialkali boranes, which upon subsequent treatment with alkaline H2O2, alkaline H2O2 gives alcohol, okay. And always remember that this reaction involves the addition of water to the double bond of boron, which is BH3, to the double bond called hydroboroxidation, and hydrolysis to give alcohol, okay. So as you can see here, in the first process, what is happening here? In the first process, this is what here, what we are using here, this one, when we are using B2S6, at that time what will happen? This double bond will break here, and what will happen? This BH2 will come and attach to this carbon. As you can see, BH2 has come and attached to this carbon, and after that, when we further oxidize with the in the presence of H2O2, when we further oxidize this in presence of H2O2, it has given what? You can see, it is given alcohol. Let me make here, it has given what? It has given alcohol, as you can see here, right? So when we talk about the mechanism of this, so mechanism is very simple. As you can see, BH3 in presence of THF, what it will form? It will form like this, right? And again, after that, when we are oxidizing it in the presence of H2O2 or OH, at that time what will happen? This will form here. In place of pH2, this OH will come, okay. This is called LT Marconif reduction, okay, orientation, okay. Now mechanism, when we're talking about the mechanism is very simple here, because since the vacant pure vital is here, so what will happen? This alkene will come to this BH, will attack to this BH3, right? And after that, what it will form? It will form like this, okay. And now next is, again, one alkene we are taking, again it is attacking to this, then it will form like this, okay. And the third case, when it is attacking to this, it will form like this, okay. No hydrogen is there. As you can see, in the first case, as you can see, in the first case, when first one alkene has attacked, at that time 2 hydrogen was there, and in the second case, you can see only 1 hydrogen. In the third case, no hydrogen is there, right? So like this will be the product here, okay. As you can see, trialkyl boron will form here, okay. So one more thing we can say here, that we can take, if it is, if R is, if we are taking here R, okay, and in place of this, in place of alkene, if in place of this, if we are taking R, so at that time what will happen? So as you can see, at that time, if you are taking R in place of B, H, OH, H, OH, H, OH, OH, H, and H, OH, so it will, what it will give it, this will react with this, and it will form this one, okay. 3R OH, alcohol will form here, H3BO3 will come out, and BOH4 will come out from this reaction, okay. So as you can see here, example, if we are taking this, if we are taking this compound, and in place of this, when you are using here this one, when Marconif off rule with the rearrangement, the product was this, right? Now again, when we are using OMDM, at that time the product is this, and when we are using here HPO, hydroboration oxidation, at that time the product is this, okay. So in the same case, as you can see, this one was the product. At that time, when we are using H3O positive, at that time we have got 1 degree alcohol. When we are using OMDM, at that time 2 degree alcohol we have got, and when we are using H3O HBO, at that time 3 degree alcohol we have got, right? So I hope you have understood this, right? Now next process is from the haloalkanes or aryl halide, okay. Now this process from the haloalkanes or from alkyl halide, this process is generally happen in two form, which is either it will be in it will form an SN2 mechanism, or it will be in SN1 mechanism, okay. So when it is forming in, when it is undergoing, and when SN2 mechanism, at that time, as you can see, this is our Br here, here is Br, right? So what will happen? In place of Br, OH will come, as you can see, okay. Here also, in place of Br, OH will come here, right, in place of Cl. Now one more thing, since SN2 reaction is taking place, right? So always remember that here, when we are talking here, in this case, let me draw here, when we are taking this, okay, the chlorine is above the plane, right? Here the chlorine is above the plane. But since the when we are taking here aqueous, when we are taking here aqueous KOH, and since the SN2 reaction is taking place, so at that time the product which we will get here, the product which we will get here, it will be below the plane, okay, because since there will be a, since we are there SN2 reaction is taking place, and there will be a there, if it is above the plane, it will be on the, it will be below the plane, right? So as you can see here example. Now next is it can either undergo with SN1 mechanism. So when it will go in SN1 mechanism, as you can see in this case, so when we talk about the SN1 mechanism, it will generally, it will be given by either tertiary or some of the secondary halide will give this, okay. Most of the time tertiary will give the SN1 reaction, right? So as you can see, when you are using here 1 degree halide, alkyl halide, so at the time in presence of acetone and water, the medium should be polar and protic, right? We have discussed about this for SN1 reaction. What will happen, this if the medium is polar as well as protic, then what will happen, this leaving, this is a leaving group, right? It will leave this, Cl will leave here. So when Cl will leave from here, then OH will come and attack here, right, as you can see here. So this was about the, this was about the preparation of alcohol from haloalkanes, right? So now next is Grignard reagent. When we talk about the Grignard reagent, we will discuss about this in detail, but I will give you today, I will give you some of the idea about the Grignard reagent. So when we are taking here Grignard reagent, as you can see here, so in Grignard reagent, this person is positive and this person is negative, right? So when we are taking here O2 and presence of H2O, it is forming like this ROH, right? Again when we are using here this one, okay, so at that time it is forming this, and again when we are taking this, at that time it will form this, okay. So here you can see the number of carbon is same. Here the number of carbon is n plus 2, means 2 carbon will add here, we will add the 2 carbon will form extra, will means the 2 carbon will be added here, okay. So here R is what, here R is either alkyl or aryl group, okay. So we will talk about this in detail in the next class. Till that we will conclude here today. I hope you have understood this, right? And this is the notes, you can copy there, copy these notes, and in the next class we will discuss about the preparation of alcohol from Grignard reagent, okay, in detail. Till that, thank you.